Okay, so if now we're doing web work 3, question number 12. So this question is about visualizing contour plot where it uses color to indicate the height of elevation. One conceptual tool I sort of use to convince myself these contour plots make sense is this example. Um, Okay, so these are terraces. They're basically fields that are elevated and spatially arranged like staircases. So basically, I'm sort of imagining taking a certain height, for example, z equals to 0. Maybe that's the line here, and we can project that contour onto a two-dimensional graph. And maybe at higher elevation, for example, z equals to 18, we have a different contour line like this. Okay, so although it's spatially arranged like this, if we look down from it, from a perfect vertical angle, maybe then we can just imagine all of these contours as lines. In this graph, it's not totally perfect, so you still sort of can see there are heights of elevation, but you can imagine if they're being flattened down on a piece of paper, they would just be a bunch of lines with the shape of each contour at different values of z. Okay, I hope that makes some sense. Now let's look at the original question. Okay, so the first one asks you to find the contour plot of f of xy equals to x squared minus 3y. Okay, so why don't we look at the case where z equals to 0 first? At z equals to 0, we have 3y equals to x squared. That gives us y equals to 1 over 3x squared. Quite simply, we know that it's going to be something that looks like this, and it's going to y equals to 0 where x equals to 0. Okay, so that eliminates C, D, E, and F. So only A and B are viable options for this question. But the difference of them is the height of elevation. So this question says the red areas represent the lowest heights and the purple areas represent the highest height. So if you're imagining these graphs as like staircases, just like we see here, from this graph where here is the lowest point I'm at, and then by moving from this direction, we're walking up the stairs, and by moving from this direction, graph A, we're moving down the stairs, if that makes sense. Okay, so how do we distinguish between which graph we choose for this particular function? So let's just set x squared minus 3y equals to 1. So at z equals to 1. Remember, this is at an elevation that's higher than this one. This one is z equals to 0. Okay, so at z equals to 1, we have x squared equals to, 3y equals to x squared minus 1, which gives a y equals to 1 over 3x squared minus 1 over 3. So this is going to have the same general shape as this one over here, which says z equals to 0. But it's going to be shifted downwards because at x equals to 0, y is going to equal to 1 over 3. So that's going to be our graph for this question. So this goes to 0 and z equals to 1. So this is basically saying if we're shifting things downwards, we're actually elevating ourselves. So that's going to, we're walking up the stairs from here to here. Okay, so that matches graph number B. Okay, so let's look at the second one. The second one, x squared plus 3y squared. Okay, so immediately we know that it's going to be an sort of oval. If we basically, if you can plot this with several points and convince yourself that, but then we can just eliminate the options A, B, D, and F. Okay, so there's C and E left. So how do we convince ourselves which exactly is question number 2? Basically, we find a plane where, for example, z equals to a squared, okay? And at this plane, let's just plot several points. Let's look at the case where x equals to 0, okay? So when x equals to 0, then we have 3y squared equals to a squared. That gives us y squared equals to 1 over 3a squared, gives us y equals to plus or minus 1 over 3a. Okay, so that's going to be somewhere like here and here. Let's say that's 1 over 3a, and this is 1 over 3a minus, okay. Then when y equals to 0, this function is going to give us x squared equals to a squared. That gives us x equals to plus or minus a. So obviously a is larger than square root of 1 over 3a, okay? That means my x equals to a is going to be here, and my x equals to negative a is going to be here. So it's going to be oval stretched in the horizontal direction, and that matches the description of the graph E, okay? And let's look at the third one. So the third one says y squared minus 3x is the function of x and y. Similarly, if we plot this graph in z equals to 0 plane, we have y squared equals to 3x, and then x equals to 1 over 3y squared. So this is going to be very similar to my graph in the other one, but like it's just going to be sort of flipped. So it's going to be something in this direction. Okay, and where this is x and this is y. So and then similarly, we eliminate A, B, C, and E, and we choose from D and F. And let's just find one other case. So this one is for z equals to 0. So let's see what happens at z equals to 1, okay? So at z equals to 1, you have y squared minus 1 equals to 3x, which will gives us x equals to 1 over 3 y squared minus 1 over 3, which is going to be here. So this is the line for z, contour line for z equals to 1. That means as I'm going from right to the left, I'm climbing up the stairs. So this one is the lower elevation, this one is the higher elevation in this graph. So as I go from right to left, I'm climbing up the stairs. And for this one, as I go from right to left, I'm going down the stairs. So obviously this one should be option F. Okay, the last one we have here is number 4. So number 4, it gives us 4 minus 3 squared minus y squared equals to f of x and y. So similarly, set this equals to 0 first. That means we're at the elevation where z equals to 0. Okay, this gives us 3x squared plus y squared equals to 4. Okay. So for example, set y equals to 0, you're going to have 3x squared equals to 4. That gives us x squared equals to 4 over 3. X equals to plus or minus 4 over 3. When we set x equals to 0, we have y squared equals to 4, y equals to plus or minus 2, and the 2 plus or minus 2, the magnitude of plus or minus 2 is obviously larger than the magnitude of 4 over 3. Okay, so y is going to be here, and x is going to be here and here. So at the elevation z equals to 0, we have a graph like this. And obviously, the one in C matches this description. Okay, so that is how we solve web work 3 question number 12. If you have any other questions, you can post on Piazza or come to the office hour to get some clarifications.